Well, let's take a look at this next unit, and we'll start with linear equations and rational equations. And our first topic is solve linear equations in one variable. So solving linear equations. We have a note up at the top. The note says, at any step, combine like terms and combine numbers. Step 1, get rid of parentheses. We do this via the distributive property. Step 2 is to get rid of fractions. And we multiply by the LCM of all the denominators. Step 3, get everything with an x on one side, numbers on the other side. Step 4, divide both sides by the number in front of the x. Okay, on step 3, when I say get everything with an x on one side, numbers on the other side, everything with an x, I'm talking about the variable terms. And numbers, I'm talking about the constant terms. And I refer to x, but you can have any variable. And then step 4, divide both sides by a number in front of the x. That's the coefficient. So we're dividing both sides by the coefficient. So let's take a look at a couple examples. Let's say I got -4 times x minus 2 plus 7 is equal to 6 times x plus 1. Now step 1. Get rid of parentheses. And we do that via the distributive property. So I'm going to take the -4 and multiply it times the x and multiply it times the -2. And I'll take the 6 and multiply it times the x and multiply it times the 1. -4 times x is -4x. -4 times -2 is 8. And I'll bring down to 7. 6 times x is 6x. 6 times 1 is 6. So we've got -4x. Always combine numbers. 8 plus 7 is 15. Step 2, get rid of fractions. Don't have any. Step 3, get everything with an x on one side, numbers on the other side. So I'll take this 6x and move it to the left side. And I'll take this 15 and move it to the right side. Remember, when you move anything across or equals, your sign changes. So the positive 6x becomes a negative 6x. The positive 15 becomes a negative 15. Our note up at top, at any step combine together like terms. -4x, -6x is -10x. And combine numbers. 6 minus 15 is -9. Step 4. Divide both sides by a number in front of your x. Well, number in front of our x is a -10. So divide both sides by -10. Now when you do that, these -10s cancel. So we got x is equal to, and these negatives cancel. And that gives us x equals 9/10. Let's say I had 1/6x minus 2 is equal to 1/9 x plus 3. Step 1. Get rid of parentheses. Don't have any. Step 2. Get rid of fractions. Multiply everything by the LCM of all your denominators. Well, we got 6 and we got 9. So we'd multiply everything by 18, the LCM of 6 and 9. So we'll multiply the 1/6x by 18, minus, we'll multiply the 2 by 18. We'll multiply the 1/9 x by 18. And we'll multiply the 3 by 18. When I say multiply everything, I'm talking about what's separated by pluses, minuses, and equals. That's why we multiply by the 1/6x. Here's a minus, so that's why we multiply by the 2. Here's an equals, that's why we multiply by the 1/9x. Here's a plus, that's why we multiply by the 3. Now 18 and 6 are both divisible by 6. 6 divided by 6 is 1. 18 divided by 6 is 3. 9 and 18 are both divisible by 9. 9 divided by 9 is 1. 18 divided by 9 is 2. So 3 times 1 is 3x minus 18 times 2 is 36. 2 times 1 is 2x plus, let's see, what is that? Let's see, 24, 54. Step 3. Get everything with an x on one side, numbers on the other side. So I'll take this 2x, move it to the left side. I'll take this negative 36 and move it to the right side. Anytime you take anything over the other side of the equals, the sign changes. So positive 2x becomes a negative 2x. The negative 36 becomes a positive 36. Always combine together like terms. 3x minus 2x is 1x, or x. And 54 plus 36 is 90. That's kind of strange. Usually when I make problems up, they don't come up nice. They come up with fractions. And that's how you'd solve a linear equation. Now, identifying conditional equations, identities, and contradictions. Let's talk about that. Let me clear this off. Okay, I'm working a problem. And I get it down to this point. Let's say I got x plus 3 is equal to x plus 5. Get everything with an x on one side, numbers on the other side. X minus x cancels, leaves us a 0 there, and 5 minus 3 is 2. Well, we have a problem. We were solving for x, and all of a sudden x disappeared. Now the question is, when is 0 equal to 2? Well, 0 is never equal to 2. So when you come up with something that can't be true, that refers to that there's no solution. There's no value I can put up in my original equation causes that to be true. Now, no solution, in terms of the wording here, matches contradiction. So that'd be a contradiction. Working another problem down. And I got x plus 2 is equal to x plus 2. Get everything with x on one side, numbers on the other side. And let me try it again. There. And x minus x cancels, 2 minus 2 cancels, so we end up with 0 is equal to 0. Well, you have to ask yourself, when is 0 equal to 0? Well, 0 is equal to 0 all the time. That is a sign of an identity. It means it does not matter what value I put up here for x, it'll be true. I could put in x equals 5, x equals 7, x equals 1 million. Whatever I put in there, it'll cause that to be true. And then our last type, working a problem down, and I actually come up with an answer. I come up like x equals 3 or x equals 1, something like that. When you come up with an answer, that's your conditional equation. It means your original equation is conditionally true when x is equal to 3. So that's how you identify the 3 different types of equations. Now, next one we're going to take a look at is solving rational equations. Let me clear this off. So solving rational equations. Our first step is to get rid of parentheses. Although you don't see that very often where they have parentheses to begin with. Step 2 is get rid of fractions. And usually what we have to do in order to do that is we have to factor all the denominators. And our second sub-step is to figure out the LCM of all the denominators and multiply everything by it. And then step 3 is solve for x. At this point, it'll either be a linear equation, and if it is, you use the 4-step method we just covered, or it'll be a quadratic equation, and you use zero factor property, which we haven't talked about yet. And then step 4 is to semi-check your answer. And we'll talk about, well, what in the world does that mean? Why not fully check it? Let's say I had I don't know if I can make one of these up or not, but let's see. 5 over x squared minus 9 plus 7 over x plus 3 is equal negative 2 over x minus 3. Hopefully this doesn't come up with a contradiction or a identity of some sort. Step 1. Get rid of parentheses. Don't have any. Step 2. Get rid of fractions. I do have fractions. First thing we do is we factor all our denominators. Grab a drink here. Okay, x squared minus 9. This is the difference of two squares. Two terms with a minus string in it. And it factors as 5 over x plus 3 times x minus 3. Can't factor the x plus 3 here, so we'll leave that alone. And over on the right side, we can't factor the x minus 3, so we leave that alone. Now our second substep says to figure out the LCM of all your denominators. So I start with the x plus 3. I'm looking for the greatest number of x plus 3's in a single denominator. There's one here, none here. So the greatest number of x plus 3's in a single denominator is 1. Then I go to my next factor, the x minus 3. And I'm looking for the greatest number of x minus 3's in a single denominator. There's one here, none here, one here. So the greatest number of x minus 3's in a single denominator is 1. So this would be our LCM, and that's what we'll multiply everything by. So we'll multiply it times our first fraction. We'll multiply it times our second fraction. We'll multiply it times the fraction on the right side. Okay. This x plus 3 cancels this x plus 3. This x minus 3 cancels that x minus 3. This x plus 3 and this x plus 3 cancel. This x minus 3 and this x minus 3 cancel. So we're left with a 5 plus 7 times x minus 3 is equal to negative 2 times x plus 3. Well, 7 times x is 7x. 7 times negative 3 is negative 21. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. And it doesn't matter where you are in math, you always combine like terms, you always combine numbers. 5 minus 21 is negative 16. Okay, so now we're down to step 3. Step 3 says to solve for x. This is a linear equation. The reason why it's a linear equation is everything's the first power. It's got an x squared, then it's a quadratic equation. So we go through our 4-step method. Get rid of parentheses, don't have any. Get rid of fractions, don't have any. If you've done your steps up here, you shouldn't have any of those. Step 3, get everything with an x on one side, numbers on the other. So I'll take negative 2x over, and I'll take negative 16 over. You take anything cross or equals, your sign changes, so negative 2x becomes a positive 2x. The negative 16 becomes a positive 16. Combine like terms in a step. 7x plus 2x is 9x. And combine numbers in a step. Negative 6 plus 16 is 10. Last step is solving a linear equation. Divide both sides by a number in front of your x. Number in front of x is a 9, so we'll divide both sides by 9. Those 9s would cancel, and then we'd have 10 over 9. And this would be maybe our answer. It would be our answer. But I would want to double check this by plugging back in my original problem, make sure it doesn't cause any denominator to equal 0. 10 ninths squared is 100 over 81 minus 9 is not 0. 10 ninths plus 3 is not 0. 10 ninths minus 3 is not 0. So that problem's fine. Now, the reason why I went ahead and circled it, because I knew the only ones that give us problems, is if we had come up with x equals negative 3. If I had plugged negative 3 back in my original problem, negative 3 plus 3 is 0. That would have caused the denominator to equal 0. Or x is equal to positive 3. If I plugged in a positive 3, 3 minus 3 would give me 0. So those are answers you can't have. But I knew this one was fine. Now our fourth topic is solving a literal equation for a specified variable. Typically we refer to those as formulas. So solving a formula for a variable. Step 1, get rid of parentheses. Step 2, get rid of fractions. Step 3, get everything with the variable we are solving for on one side, everything else on the other side. We're talking mostly terms here, but they don't have to be terms. You could have any kind of expression. Step 4, if possible, factor out the variable you are solving for. You will have 2 or more of that variable if you can do that step. And then step 5, divide both sides by what is in front of / back of the variable we are solving for. Let me clear these off. If I had volume is equal to 1/3 pi r cubed. I don't know if that's a valid formula or not, but let's say it is. No, I want to throw an h in there, sorry. And I want to solve this for h. Might have been r squared, but okay, we'll go with that. Well, first step, get rid of parentheses. Don't have any. Second step, we want to get rid of fractions. You multiply everything by the LCM of all your denominators. We only have one denominator, so that is our LCM. So we'll multiply everything by 3. We'll take 3 times b, and we'll take 3 times 1/3 pi r cubed h. Those 3's would cancel. So we'd have 3b is equal to pi r cubed h. Now step 3, get everything with a variable you're solving for on one side, everything else on the other side. We're solving for h. All the terms with h is on the right side, and all the other terms are over on the left side. So that's done. Step 4, factor out the variable you're solving for. You can only do that if you have 2 or more of that variable. See how we only have one h here? If we had 2 h's on this side, then we could do that. And step 5, divide both sides by what's in front of / back of the variable you're solving for. There's nothing behind it, but there's a pi r cubed in front of it. So we'll divide both sides by pi r cubed. Now when we do that, these pi's cancel, and these r cubes cancel. And so we have h is equal to 3b over pi r cubed. And that'll be your answer. Your goal is to get the variable by itself. Let's say I had 1 over r is equal to 1 over r sub 1 plus 1 over r sub 2. I think this is some kind of electrical formula, though these might be i's. I don't really remember. Let's say I'm solving for r sub 1. Now r sub 1, r sub 2 are different variables. The reason why these 1s are here to indicate these are all r, whatever r might stand for, but the r sub 1 and r sub 2 are different than the r. Okay, step 1. Get rid of parentheses. Don't have any. Step 2. Get rid of fractions. Multiply everything by the LCM of all your denominators. It's easy when you have different variables like this. Your LCM is just the 3 multiplied together. So our LCM would be r, r1, r2. We'll multiply that times our first fraction. We'll multiply that times the second fraction. And we'll multiply it times fraction on the far right. When we do that, this r cancels with this r. This r1 cancels with this r1. This r2 cancels with this r2. And so we're left with r1, r2 is equal to r2 plus r1. Now step 3. Get everything with a variable you're solving for on one side, everything else on the other side. So we're solving for r1, so I want to get everything with an r1 over on the left side. So I'm going to take this r1 to the left side. Remember, when you take anything across 3 equals, your sign changes, so the r1 becomes a negative r1. Step 4. If possible, factor out the variable you're solving for. We're solving for r1, and I said you'll have 2 or more of that variable. See how we have 2 r1s? So we're going to factor out an r1, and that gives us r2 minus r is equal to r2. And then step 5, divide both sides by what's in front of / back of the variable you're solving for. There's nothing in front of the r1, but there's an r2 minus r after it. So we'll divide both sides by that. Now when we do that, this r2 minus r cancels with this, and we're left with r1 is equal to r2 over r2 minus r. And that's our answer. Grab a drink here, and we'll look at the next topic. Okay, let me clear this off. Now I'm going to skip over these word problems. I'm not very good at making word problems up, so if you have any you can't figure out, just click the message my instructor, and I'll help you with those. Now complex numbers. Let's talk about those. We got the standard form of a complex number. Now it looks like this. A plus BI. Now A is our real part, and the BI is our imaginary part. Now the question becomes, what is I? I mean, it's obviously our imaginary part, but how do you get the imaginary part? Well, if you have the square root of -1, that is what gives you an I. Now, you always write your problems in standard form, even if it doesn't say to. Now, let's say I had square root of -25, and I'm trying to simplify that. Well, that'd be a square root of -1 times 5 times 5. Now, remember with square roots, we're looking for a pair of something. Here's a pair of 5s, so this pair of 5s is going to come out in front as a single 5. And we're left with a square root of -1, and we said square root of -1 is equal to I. So that would give us 5I as our answer. Now you may have some problems that don't work out as nice as that. Like if I had square root of -24. If I did the prime factorization of it, I'd have -1 times 2, 4, 8 times 3. So there's the prime factorization. We're looking for a pair of somethings. Here's a pair of 2's. They're going to come out in front as a single 2. And here's a -1. Now it'll come out as an I. So we're going to have 2I, and we're left with a 2 times 3 inside, which is 6. So our answer there would be 2I square root of 6. Now let me clear that off. And let's take a look at some operations dealing with I. Let's say I'm adding 3 plus 2I plus 7 minus 5I. For the most part, you treat the I like another variable. Now here, these parentheses aren't doing anything, so I can drop them. And I can even rearrange them, so put the real parts together, 3 plus 7, and put the imaginary parts together, 2I minus 5I. So we'll combine the numbers, 3 plus 7 is 10. And remember I said you treat I as like a variable. So 2I minus 5I is -3I. And that would be our answer. Now let's look at subtraction. Let's say I had 10 minus 2I minus -3 plus 5I. Well, first thing we're going to do is we're going to get rid of the parentheses. Now, first set of parentheses isn't doing anything, so I can drop it. 10 minus 2I. Remember, a negative out in front of your parentheses flips the sign of everything inside. So that's going to flip the sign of the -3 and the 5I. So the -3 becomes a +3, and the positive 5I becomes a -5I. And then we're going to combine together numbers. We've got 10 plus 3, which gives us 13. And we're going to combine numbers, or i's, I mean. -2I and -5I gives us -7I. And those will be our answers. Now, occasionally, you'll have an I squared in your problem. And we're going to talk more about the powers of I here in a minute. But I squared is equal to -1. Standard form says you cannot have I squared or above. You got to have just I to the first power. Now, if you're wondering where's that come from, remember square root of -1 is equal to I. Well, if I were to take both sides of the second power, the square root and the second power cancel, gives us -1, and I to the second power is I squared. So that's where you get this fact. Now, where you use that at, the first operation we'll look at, is multiplication. So if I have 3 plus 2I times 5 plus I, and we're multiplying those together. Well, we're going to take the 3 here, And we'll multiply it times the 5, and we'll multiply it times the I. And then we'll take the 2i and multiply it times the 5 and multiply it times the I. So we're going to have 3 times 5. We'll have 3 times I. We'll have 2i times 5. And we'll have 2i times I. I'm just following the lines to see what to multiply together. Or this is foiling. First, outer, inner, and last. 3 times 5 is 15. 3 times I is 3i. 2i times 5 is 10i. And then 2i times I is 2i squared. Remember what I said, you treat it just like a variable. X times x is x squared, and I times I is I squared. So we got 15. 3i plus 10i is 13i. And we can't have an I squared, but I squared we said is equal to negative 1. So we're going to replace the I squared with negative 1. So we got 15 plus 13i minus 2. 15 minus 2 is 13, so we got 13 plus 13i. And that's our answer. Now let's take a look at division. There's two types of division, and we don't actually divide. Main idea with division was trying to put it in standard form. One type you have is where you have a single item down here with an I in it. Now you might have a number with it too. This could be 5i, but you have an I down there. How you handle it when you got a single item down there with an I is you simply multiply the top and bottom by I. 3 times I is 3i. I times I is I squared. And remember what we said. We said I squared is equal to negative 1. So replace the I squared with negative 1. And 3i divided by negative 1 is negative 3i. And that's our answer. Now, let's say I had, and it's still with an I in the denominator, but this time I also got a real part with it. So in this case, 3 plus I. What you do is you multiply the top and bottom by the conjugate of the bottom. Conjugate would be 3 minus I. And whatever you multiply by the bottom, you'll multiply by the top. Now what a conjugate is the first part's the same, 3, 3. The last part's the same, I. But the sign in the middle is different. Yeah, this is a positive and this is a negative. So up on top, I'll multiply these together. So I got 2 times 3 and 2 times negative I. 2 times 3 is 6, minus 2 times I is 2i. Now, the nice part about conjugates is all you have to do is multiply your first parts together and your last parts. So we got 3 times 3, and we got I times negative I. So that's going to give us 6 minus 2i over 3 times 3 is 9, and I times negative I is negative I squared. We said we can't have I squared though, so I'm going to replace the I squared with negative 1. So then we got 6 minus 2i, and negative gives us positive, so we got 9 plus 1, which is 6 minus 2i over 10. And for our complex numbers, we always want the real part separate from the imaginary part. So at this point, I'm going to put the 6 over the 10 minus 2 over the 10 with an I to the side. So we're separating the real part from the imaginary part. And both of these fractions simplify. 6 tenths reduces to 3 fifths, minus 2 tenths reduces to 1 fifth, with an I to the side. And that's our answer. Let me grab a drink here. The little room gets kind of warm here, especially when my wife comes home and turns the heat on. Okay, powers of I. Let me erase this. I'm not going to show how to derive the powers of I. So powers of I. We got I to the first power, which is I. We got I squared, which is negative 1. We got I to the third, which is negative I. And we got I to the fourth, which is a positive 1. And then they repeat. I to the fifth is I to the sixth is negative 1. I to the seventh is negative I to the eighth is 1, and so on. Well, let's say I had I to the 202nd power. I probably don't want to create the table out that far to 202. So there's a shortcut way of doing this. You're going to take your power, which is 202, and you always divide it by 4. And this is old school division with remainders and so forth. 4 goes in 25 times. 5 times 4 is 20. And subtract that disappears, and we got a 0 here, and that brings down to 2. 4 doesn't go into 2, so that's 0. 0 times 4 is 0, and then subtract that, and you end up with 2. So this is 50 with a remainder of 2. Now, we can rewrite this as I to the remainder when we've divided by 4. So I to the 202nd power becomes I squared. And I squared is equal to negative 1. And that would be our answer. Now, the one that's missing here, which you do run across occasionally if you get I to the 0 power. But anything to the 0 power is always equal to 1. So that's kind of the oddball case that isn't covered with this powers of I table. And that's all of our operations and various items we do with complex numbers. So let's go down to quadratic equations. Let me erase this. And we have something called the zero factor property. And this says if you got something times something else equal to 0, then you can set each factor equal to 0. That's pretty vague what I just said. If you got something times something else equal to 0, but it really is as vague as what I just indicated. I haven't been checking to see where my microphone's at. Yeah, it's about the right place. So if I had, for example, x squared minus 10x plus 16, yeah, that'll work, equals 0. Now our zero factor property. The name tells you what to do. 0. You have to get 0 on one side, which we have. Factor. That says to factor the other side. Well, this will factor using the PST method. So this factors as x minus 8 times x minus 2 equal to 0. So if you get 0 on one side and you factor the other side, you can apply this property. And that says you can set each factor equal to 0. So I'll set x minus 8 equal to 0. And x minus 2 equal to 0. And then you solve those and you get x equals 8 and x equal to 2. And those would be your answers. Now that was they call it the zero product property. I call it the zero factor property, but same idea. Now next topic is the square root property. So let's talk about that. Let me clear this off. Square root property. This says if you got something squared equal to something else. Now, that's pretty vague. Then you drop the squared and you put a plus or minus square root on the other side. It really is as vague as what I just said. As long as you have this entire left side squared equal to something else, you can apply this. Let's say I had x squared is equal to 25. Now notice the entire left side squared, so that fits the form. And our square root property says you drop the squared and you put a plus or minus square root around the other side. Now I can simplify 25 inside of a square root. 25 is 5 times 5. So we're looking for a pair of somethings. Here's a pair of 5, so they're going to come out as a single 5. So we end up with x is equal to plus or minus 5. Now what that notation means there is you're going to have x equals negative 5 and x is equal to positive 5. And those would be your answers. Now let's say I had this one right here. 3x minus 1 squared is equal to 16. We can apply the square root property again because we got the entire left side squared. So square root property says we drop our squared and we put a plus or minus square root on the other side. Well, square root of 16 is 4. So that simplifies. Now I'm trying to get x by itself, so I take negative 1 over. That's equivalent to adding 1 to both sides. So we get 1 plus or minus 4 on the right side. And then I'll divide both sides by 3. And those 3's cancel. And we got x is equal to 1 plus or minus 4 over 3. Now if your radical disappears completely, it's probably going to be beneficial for you to split this into 2 separate pieces. What that plus or minus means is it means I'm going to have 1 plus 4 over 3, and I'll have 1 minus 4 over 3. 1 plus 4 is 5, so we get 5/3. 1 minus 4 is negative 3, so we got negative 3 over 3, or negative 1. And those will be our 2 answers. Now I'm going to show one more of those, and then we'll go on to the next type. Let's say I had x plus 2 squared is equal to, let's see, 18. Well, square root property says we drop our squared, and we put a plus or minus square root on the other side. Sometimes the radical doesn't disappear. In this case, the prime factorization of 18 is 2 times 3 times 3. We're looking for a pair of somethings. Here's a pair of 3s, so this pair of 3s is going to come out in front as a single 3. And then I'll take the 2 over. So we got x is equal to negative 2 plus or minus 3 square root of 2. And that'd be our answer. I want to show one where the radical didn't disappear. Now the next topic we're going to take a look at is completing a square. Okay. Let's see, completing the square. Step 1. Divide everything by the number in front of the x squared. Step 2, take the number, the constant term, to the right side. Step 3, take the number before the x, the coefficient, multiply it by 1/2, square it, and add to both sides. Step 4, back to the left side. And step 5, use the square root property to solve for x. Okay, let me clean this off. Let's say I have x squared minus 4x plus 1 equals 0. Step 1. Divide everything by the number in front of the x squared. Now there is no number in front of our x squared, so I don't have to do that. Step 2. Take the number of the constant term to the right side. So I take the 1, move it over. So we got x squared minus 4x is equal to negative 1. Step 3. Take the number before our x, which is negative 4, multiply it times a half and square it. It's always times a half and it's always squared. Negative 4 times a half is negative 2, and negative 2 squared gives us a positive 4. And then add to both sides. So we're going to have x squared minus 4x plus 4 is equal to negative 1 plus 4. So that gives us x squared minus 4x plus 4 equals negative 1 plus 4 is 3. Step 4. Factor the left side. This will factor as x minus 2 squared. There's a trick to it. Whatever number is right here, right before you square it, sign included, is always what goes in at this point. So there is no factoring involved. Step 5. Use the square root property to solve for x. Square root property says you drop your squared and you put a plus or minus square root on the other side. Now take the negative 2 over, so we get x equals 2 plus or minus square root of 3. And that would be our answer. Now, our fourth topic in this section is to solve using the quadratic formula. So let's take a look at that. Let me clean this off. Now, quadratic formula is when you got the form ax squared plus bx plus c equals 0. And if you got in that form, your quadratic formula says your answer is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So if I had x squared minus 7x plus 3 equal to 0, and I'm wanting to solve it using the quadratic formula. Well, first off, you have to have 0 on one side, which we do. You then identify your a, b, and c. A is whatever number is in front of your x squared, and there isn't a number there, so it's by default 1, invisible 1. B is whatever number is in front of your x, so that's negative 7. And c is your number at the end, a constant term, which is 3. Now, it's always best, if you mess up on signs anyway, to go through and replace all of your variables with parentheses. So we're going to have negative b plus or minus b squared minus 4 times a times c all over 2a. So now everywhere I had a b, I'll put in negative 7. Everywhere I had an a, I'll put in 1 in my formula. And everywhere I had a c, I'll put in a 3. So we get x is equal to 7 plus or minus square root, negative 7 squared is 49, minus 4 times 1 times 3 is 12, over 2. So we got x is equal to 7 plus or minus 49 minus 12 is 37, over 2. And that would be our answer. 37, I believe, is prime, so it doesn't break down any. Now using the discriminant. Let me clear this off. And let's talk about the discriminant. Discriminant is a piece of the quadratic formula. If you have the problem of the form ax squared plus bx plus c equals 0, then your discriminant is going to equal to b squared minus 4ac. You notice this is just the part that was underneath the square root. Now we're going to have three cases of that. Case 1 is where it is positive. That means that you're going to have two real answers. So like, for example, if you end up with 7, it's positive, so you have two real answers. They're actually going to be different, unique. Now case 2, it is negative. That means you're going to have two answers with imaginary parts. Some books mistakenly say they're complex numbers, but actually in the scheme of things, a real number is actually a complex number. So coming up with x equals 2 and x equals 5, those are both complex answers. Case 3 says it is equal to 0. That means you're going to have one answer, it'll be real, and it'll be repeated. So for example, if I have x squared minus 7x plus 3 equals 0, well, I need my a, b, and c again, so I'll identify those. A is whatever number's in front of our x squared, which is 1. B is whatever number's in front of our x, which is negative 7. And c is our number at the end, which is 3. So we got b squared minus 4ac. So we're going to have negative 7 squared minus 4 times a times, these are the same numbers I used before, weren't they? 49 minus 12 equals 37. Now this is positive. So this says, case 1 is positive. You have two real answers, you're unique. So two real answers, and they're unique. Now you might look at that and say, well, geez, if you're going to go to all that effort, you might as well just solve it. It wasn't that much harder to do the rest of it. Well, yes. This is really meant if you're going into programming. If you're going to program the quadratic formula, then it's beneficial to know how many answers you have and what type you're going to have. It helps you to write the program. If you're going on in some areas in mathematics, use there, but that's really the only place most of you will ever see it, assuming you're going into programming. Okay. Solve an equation for a specific variable. That's solving a formula for a variable, and we're seeing different types like that. You just may have to use the square root property to get the variable by itself. Okay, we're going to skip the applications, and we'll come down to section 1.6. Now we're going to solve a polynomial equation. And I think I got one here. A polynomial equation. This would be a good example. I can't make these up, so I went ahead before I started and located some of these. These take a lot more thought to make up. X plus 2 is equal to 4x to the third plus 8x squared. Now this is a polynomial equation. And remember the zero factor property where we had to get 0 on one side and we factored the other side? That's no different here. Factoring's harder. So we need to get 0 on one side. So I'm going to take the 2, move it to the right side, and I'll take the x and move it to the right side. So I'm going to have 0 is equal to 4x to the third plus 8x squared minus x minus 2. Now the factoring you'd use at this point is grouping, because we've got 4 more terms. So group first two terms together, group last two terms together. Now the first two terms have a 4 and an x squared in common, the GCF, and that leaves us x plus 2. The last group doesn't have anything in common, but my first term is negative. We always factor out a negative 1 if the first term is negative. And that leaves us x plus 2. Now our goal was to get these parentheses the same, which they are. So now factor out an x plus 2. And that leaves us 4x squared minus 1. Now 4x squared minus 1, that's a difference of two squares, because we got two terms with a minus string in it. And that factors as x plus 2 times 2x plus 1 times 2x minus 1. Now the zero factor property says you get 0 on one side, you factor the other side, you're going to set each factor equal to 0. So I'll set x plus 2 equal to 0, 2x plus 1 equal to 0, and 2x minus 1 equal to 0. We have three factors, but it's exact same principle as what we saw before. Now here I'll take the 2 over, it becomes a negative 2. Here I'll take the 1 over, it becomes a negative 1, and then divide both sides by 2, and we get negative 1/2. Here I'll take a negative 1 over, it becomes a positive 1, divide both sides by 2, and we get 1/2. And those would be our three answers. Now our next topic is solving rational equations, but that's really no different than what we saw before. The difference here is sometimes when you get rid of the fractions, you may have a quadratic equation to solve at that point. And I got examples out there you can take a look at. But let me grab a drink here. And let's take a look at radical equations. So solving radical equations. Step 1, get a radical by itself on one side of the equals. We'll talk more about what that means. Step 2, raise both sides to a power equal to the index. Step 3, if more radicals, go back to step 1. Step 4, solve for x, and at this point it might be a linear equation, and you use the 4-step method that we looked at, or it might be a quadratic, and you use the zero factor property. And then step 5 is to check your answers. This process will give you the correct answers, but sometimes it gives you false answers also. So you have to fully check each one of your answers you come up with. Let me clear this off. Let's say I have the square root of 3x minus 1 is equal to 4. And we'll go through our steps. First step is to get a radical by itself on one side. When I say by itself, there's nothing in front of it, there's nothing after it. You just simply have the square root there. Occasionally you'll have a number in front of it with multiplication, because on step 1 you do not want to create any fractions. Step 2, raise both sides to a power equal to the index. The index, remember, is whatever number is in this slot right here, and if there isn't a number, it's by default 2. So we're going to square both sides in this case. Now when you square a square root, when the index matches the power, they cancel each other away. So that's going to give us 3x minus 1, and 4 squared is 16. Now this, there are no more radicals, so I go to step 4, and this is a linear equation. So we're going to get everything with x on one side, numbers in the other. So I'll take the negative 1 over, and it becomes a positive 1. 16 plus 1, 17, and then divide both sides by 3. And we get 17 thirds, maybe. We have to check that. If I plug 17 thirds back up here, the 3's would cancel. I'd have 17 minus 1, which is 16, and square root of 16 does give us 4. So that checks. Now let me look at a little bit more challenging problem than that. I think this is one that's interesting, if I remember right. We got x minus the square root of negative 2x plus 7 equals 2. We're going through the same steps. First step says to get the radical by itself. So I'm going to take this negative square root, move it to the right side, and I'll take this 2, move it to the left side. When you move anything across or equals, your sign changes, so the positive 2 becomes a negative 2, and the negative square root becomes a positive square root. Step 2. Raise both sides to a power equal to the index. Well, this is a square root again, so we'll square both sides. So we got x minus 2 squared is equal to the square root of negative 2x plus 7 squared. Now x minus 2 squared, that's x minus 2 times x minus 2. And over on the right side, when the index matches the power, they cancel each other. So that gives us negative 2x plus 7. Now over here, I'm going to FOIL this. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. Always combine together like terms. Negative 2x is negative 4x. And now step 2. Now step 3 says if you have more radicals, go back to step number 1. We don't have any more. Now we go down to step 4. And this is a quadratic equation. The reason why this is a quadratic equation is it's got an x squared. Now we want to get 0 on one side. So we're going to take the negative 2x, move it over, and we'll get 7 and move it over. So we got x squared minus 4x plus 2x plus 4 minus 7 equals 0. Combine like terms. Negative 4x plus 2x is negative 2x. 4 minus 7 is negative 3. Now this will factor using the PSD. So this factors as x minus 3 times x plus 1. Now the zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x minus 3 equal to 0 and x plus 1 equal to 0. Which gives us x equals 3 and x equals negative 1. Maybe. Remember, we have to check our answers. If I put 3 back up here, negative 2 times 3 is negative 6, plus 7 is 1, square root of 1 is 1. So we have 3 minus 1, which does give us 2. Now if I put negative 1 in here, negative 1, negative 2 times negative 1 is a positive 2, plus 7 is 9, square root of 9 is 3. Now if I put negative 1 here, we got negative 1 minus 3, that does not give you 2. So that crosses off. And our only answer is the x equals 3. Now it also tells us to solve equations with rational exponents. So let's talk about those. Let me clear this off. There's a specific type they're talking about here. Rational exponent means a fractional power. Solving equations with a single fractional power. Rational exponent. Step 1. Get the part with the fractional power by itself on one side of the equals. Step 2, raise both, or write the it may not be as a fractional power at that point. So you may have to put it into a fractional power. So write the exponent in fractional power form. I might be saying, well, yeah, but you said solve equations with a single fractional power. Well, we'll talk about that. Step 3. Raise both sides to a power equal to the reciprocal of the fractional power. Now, if our original numerator is even, we put a plus or minus. If the original numerator is odd, no plus or minus. And then step 4, solve for x. And it'll either be a linear equation or quadratic at that point. And then step 5 is to check your answers. Anytime you raise both sides to a power, it's good practice to always check your answers. Okay, well, let's see what in the world I mean here. Let's say I had x to the 2/3 power is going to equal to 9. So we got a fractional power here. Step 1, get the part of the fractional power by itself on one side of the equals. It's by itself. There's nothing in front of it, there's nothing after it. We just have x to the 2/3 power. Step 2, write the exponent in fractional power form. Well, it's already in fractional power form, so that's good. Step 3, raise both sides to a power equal to the reciprocal of the fractional power. Reciprocal means fraction flipped, so we're going to take both sides to the 3/2 power. Now, if your original numerator is even, you put a plus or minus. What I mean by that, before you raise both sides to a power, if this is even, that means we're going to put a plus or minus. So we have to put a plus or minus on this other side. Now here, the 2's cancel, the 3's cancel. We got x is equal to plus or minus 9 to the 3/2 power. Now to simplify this, whenever you have a fractional power where the numerator is greater than 1, you put the numerator on the outside of a set of parentheses. So put the 3 on the outside of a set of parentheses like that. Now, as a placeholder, you put a 1 where the 3 used to be. Now you're going to rewrite what's inside the parentheses in radical form. This will be the square root of 9. Now square root of 9 is 3, and then that third power carries down, and we end up with x is equal to plus or minus 27. And I'd need to check those. I'd need to plug both of them in, make sure they work, but they both work. I won't waste time on that. Okay, now imagine I have x plus 1 to the 5th power is equal to, let me think this through. 32 is a good one. Now I might look at this and say, well, that's not a fractional power. We can write it as a fractional power. So we can rewrite this as x plus 1, and we can always create a fraction by putting it over 1. So I can do 5 over 1. Now we're going to raise both sides to a power equal to reciprocal. Reciprocal means fraction flipped. So we'll raise both sides to the 1/5 power. The original numerator is odd. So if I look up here, this is odd. So that means no plus or minus. So we don't put a plus or minus on this side. 5's cancel, the 1's cancel. We got x plus 1. 32 to the 1/5. If I rewrite that in radical form, that's the 5th root of 32. which ends up giving us 2. I then take the 1 over, so we got x is equal to 2 minus 1, or x is equal to 1. So those would be the two types you'd run across on these. Now, our fourth topic in this section is solve equations in quadratic form. Let me grab a drink here. Sometimes this is called a U substitution. Solving using the U substitution. Step 1. Let the middle part be equal to U, and the first part be equal to U squared. Now step 2 says solve for U, whatever that means. And step 3 is plug U equals blank back in and solve for x. This is probably one of the most vague processes there is in math. Has to be for a reason. Let me clear this off. And let's say I have x to the fourth minus 5x squared plus 6 equals 0. Now, when you can use a U substitution is if you can take your middle part here, excluding the number in front, the coefficient. If you can take your middle part, which is x squared, raise it to the second power, and it gives you this first part. That's when you can do the U substitution. Step 1. Let the middle part be equal to U, and the first part be equal to U squared. It never includes a number in front, the coefficient. So we rewrite this as U squared minus 5U plus 6 equals 0. Now step 2 says solve for U. Well, this will factor using the PSD. So this factors as U minus 2 times U minus 3 equals 0. Zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So set U minus 2 equal to 0 and U minus 3 equal to 0. So that gives us U is equal to 2 and U is equal to 3. But then step 3. Plug U equals blank back in. So whatever we said U is equal to right up here is now where we're going to plug in. We said U is equal to x squared, so we're going to replace the U here with x squared. And at this point, it might be all kinds of different techniques you'd use to solve for x. This is the square root property. Anytime you have something squared equal to something else, you can use square root property. And that says we drop our squared and we put a plus or minus square root around the other side. Drop our squared, put a plus or minus square root around the other side. And those would be our answers. Plus or minus square root of 2, plus or minus square root of 3. Now the next section. I'm not going to have time to do all of it, but I'll go ahead and at least show the solve linear inequalities in one variable. So I'm going to write down the steps for that. Solving linear inequalities. Step 1. Get rid of parentheses. Step 2. Get rid of fractions. Step 3. Get everything with an x on the left side, numbers on the right side. And step 4. Divide both sides by the number in front of the x. Note, if you multiply or divide both sides by a negative number, you flip the inequality symbol. So let me clear this off. So if I had 1/3 x minus 5 is less than 7x plus 2. And do I want that? Yeah, let's make that negative 7x plus 2. Step 1, get rid of parentheses. Don't have any. Step 2, get rid of fractions. Multiply everything by the LCM of all your denominators. We only have one denominator, so that's going to be our LCM. So we're going to multiply 3 times 1/3 x, and here's a minus, so we'll have 3 times 5. Here's the inequality symbol, so we got 3 times negative 7x. Here's a plus, so we'll have 3 times 2. When figuring out what to multiply by, it's whatever is separated by pluses, minuses, or inequality symbols. Now these 3's going to cancel, and I got 1x or x minus 3 times 5 is 15. It's less than 3 times negative 7 is negative 21x, and 3 times 2 is 6. Step 3. Get everything with an x on the left side, numbers on the right side. So I'll take negative 21x, move it over. And I'll take this negative 15 and move it over to the right side. So I'm going to have x plus 21x is less than 6 plus 15. Combine like terms at any step. X plus 21x is 22x. 6 plus 5 is 21. Well, that almost came out perfect. And then step 4. Divide both sides by number in front of your x. Number in front of x is a 22, so we're going to divide both sides by 22. And we got x is less than 21 over 22. Those 22's cancel. And that's an example of solving a linear inequality. Now I'm going to go ahead and stop the recording here, and then I'll answer any questions you have over anything.